Our next slide illustrates the angle of elevation. This is the book definition. The definition I like to give is if a person is standing here and has a direct horizontal line of sight, then that person looks up. The angle generated from that horizontal line of sight to the upward position generates an angle of elevation. The next slide shows an angle of depression. Again, this is the book definition. But if we use the definition I just used, which is, again, a person has a horizontal line of sight and then looks down, the angle generated by that horizontal line of sight and him looking down or her looking down would generate an angle of depression. In general, an angle of elevation or an angle of depression are generated from a horizontal line of sight. Therefore, the angle generated must be adjacent to the horizontal line. That angle of elevation or depression is never adjacent to the vertical line. The next slide shows a procedure used to solve problems involving angles of elevation and depression. Step 1, draw a sketch. Step 2, use the sketch to write an equation, probably using trig functions. And step 3, solve the equation and check that your answer makes sense. Let's look at an example. The length of a shadow of a tree that is 22.0 meters tall is 28.34 meters. Find the angle of elevation of the sun. The sun in this diagram will create a shadow from the tree. They said that the shadow length from the tree base is going to be 28.34 meters. And if I assume that I drop a vertical line to the base, that will generate a 90-degree angle. And that gives us the height of the tree, which is 22.02 meters. Then it asks me to find the angle of elevation. Well, my right angle is already known. So my angle of elevation has to be either one of the acute angles. Recall from the previous slide, I said that the angle of elevation or depression must be generated from a horizontal, and it cannot be adjacent to a vertical line. So therefore, this is our angle I'm solving for, which I'll call theta. Now I need to identify the triangle based on that given angle. Here, 22.02 is my opposite leg to that angle, and 28.34 is the leg that helps form that angle, so that's my adjacent leg. Now I need to find a trig function that associates itself to opposite leg and adjacent leg. That function is tangent. So my tangent theta, or tangent of an angle, is equal to opposite leg over adjacent leg. I know two of the values, so therefore all I need to do is substitute in and use a calculator to solve for my angle. So when I do that, I get tangent of theta equal to opposite leg, which is 22.02, over adjacent leg, which is 28.34. Now, all I need to do is to plug that into my calculator and solve for the problem. Now, recall here that this is an angle. Therefore, this is a trig value that is a decimal if I use a calculator. So what I need to do to find an angle is to use the inverse function of tangent. Therefore, in a calculator, I need to press second tangent first, then enter the value of that function, which is 22.02 divided by 28.34. And calculating, I get my angle of elevation to be, when I round to the nearest tenth, 82.7 degrees.